Call back at you from Supermicro, continuing on with lifecycle management of an MI300 series accelerated compute, the AMD Instinct platform. So in the previous video clip, we really focused on pod view, right, of how you manage or manipulate various different drawer locations within the rack for rack slot unit information. So we're going to continue on. So what do we do next, right? What do we do next in providing lifecycle management? So we're now sort of maybe teeter-tottering between day zero and day one activity. Maybe we want to now take a look at out-of-band management, sensor data that we're providing through Redfish. So our source of truth is basically Redfish. So Supermicro is obviously leading the industry in Redfish adoption, providing rich attributes and collection of important attributes of a server platform. And so we have agents, these intelligent agents that are running under architecture that take that data, which are called Redfish endpoint schemas, collect them up, and package them up into a unified dashboard experience that you can maintain lifecycle management. Through this process, all of that metadata is collected through an encrypted connection to your BMC. So in the previous proprietary platforms, our friends across the aisle are collecting raw commands through IPMI interface. Supermicro obviously did this as well. And earlier adoptions of the SSM platform through raw commands or cryptic commands that we provide. All of that information was passed in clear text along the wire. So now with Redfish adoption, all of that metadata attributes are pushed or pulled from agents that all of that metadata is encrypted in a tunnel, and none of that information gets exposed on the wire. So that's why it's important to utilize an open standards platform, not only for adoption in the industry, for standards based, but also, quite honestly, for security, that you don't want any of this metadata basically passed on the wire, right? And protected just in case there's some type of impersonator comes in, such as an entity or some type of subsystem gets basically rogue or basically gets into your management platform or management infrastructure and starts impersonating appliance or a device or a subsystem and collects this data and exposes it from a security vulnerability issue for a cyber attack or something like that. So what do we do next, right? So the next thing is we're going to navigate into the monitoring detail, which is the out-of-band information through Redfish subscription services. So now we're looking at a data center view of really system status, system performance across all of the racks within your data center. And so we provide a carousel view on the top here once it finishes its particular collection mechanism. You can see the icon here. It was in a cloud type of emblem indicating we were collecting this data, packaging it up, and providing it within our unified dashboard experience. So you can see here, we roll up different critical roll-up information. So you have Redfish that has three types of elements that shows based on critical event versus warning, and also in good standing as far as the platform. So we roll up all of that based on a tree architecture on the side here. So if you're seeing any component failure, specifically maybe to a multi-chassis device, you want to expose that. We roll all that information up to a rack level and then off to a pod level. So you have full visualization and observability within your entire data center, really what's going on. It shows you elements, showing you critical elements, showing you 15 types of systems that are in good standing. 6 are represented in critical status. So we'll look at what causes a critical status to occur, and how can we navigate and find out what's going on within our environment. So a lot of this stuff we're doing is artificially simulated to be able to produce various different alerts within our management platform to provide really a real look and feel of what's happening with your data center. So let's drill down and take a look at the monitoring detail of this MI300 Accelerated Compute. So in the tree view portion here, it's representing basically different pods that exist within the data center. So we've taken all of that information visualized, which is location information within pod view. We pulled it into now the monitoring detail for you to easily navigate and drill down to a particular appliance or device, or finding out what component is failing within an actual uh, device or appliance. Can you get this information based on BMC? Absolutely, right? But that is only a one-to-one relationship. You can only get information if you log into the BMC for that particular device or appliance. So that doesn't really scale well, right? It doesn't allow you for enterprise management solution one-to-many. So you have many systems you want to look at information about redfish, or look at information about alerts or sensor data you want to pull from a particular server. So it's important to have an enterprise management solution like SCC to provide you the ability to scale. Like, what happens if you had 20,000 systems that you wanted to look at and you wanted to drill down and find out one of those compute systems, why it was providing you an alert, or it's informing you there's a problem within your data center. So how would you be able to, from your seat, determine what that is the case, right? I mean, in the old days, we sent out a search party into the data center through a crash cart to determine that, and we would look at different LEDs and lights and try to drill down. And that took time, right? That took time to be able to isolate what the server was causing problems, right? We wanted to find out what was going with it. So we're giving you a tool set that you can monitor and manage within a network operations center to easily identify what those servers are causing problems, right? Because a system that has been compromised, any workload, any abstraction layer, platform as a service type offerings such as SAP or VAST or Weka, or your LLM models are running, you want to be able to identify bare metal, right, what's going on with that server, right, to be able to make sure you maintain high availability in a hardened data center for each of your servers. So let's click on the liquid cooled. Remember, we were talking about the B6 liquid production environment. So that was the pod we were looking at. And you can look at sensor data just specifically for this rack, right? Showing you system performance, various information within this rack, and being able to look at power information, a lot of detail, right? And you can click here and look at other information such as the power supply data, right? Or the thermal data, right, of this rack aggregated, or the number of systems that have been deployed. We call that a composed node, right? And you have a date picker on the right-hand side where you can go back and do historical trending, and then also have power supply information. So this is all detailed at a rack level, right? So as I mentioned before, we are looking at various different devices within that rack. And then maybe there are components within that rack we want to see. Maybe you're running a multi-chassis system that you want to look at each individual node and the power consumption and various different sensor data you want to pull from out-of-band management specifically to that chassis. I mean, and then you want to be able to look at a rack level, right? And you have just information about a rack. And maybe you want to combine aggregate of all those racks at a pod level and be able to look at power consumption and various things. So SCC provides all of that observability or all that information at your fingertips that you can basically navigate around and look for specifically what you're looking for, whether it be sensor data, whether it be alerting associated with server, a component failure. All of this is available to you. All right, so we're going to click on the tree view again, and we're going to drill down now to that particular rack. And on the left-hand side, you can see here some question marks. So, gee, Kevin, what is that? What do you mean by question marks? Well, that particular BMC has failed to send metadata or a ping to our agents. So our agents are constantly monitoring the BMC to determine if they've gone offline. And if they've gone offline, then we no longer are able to collect out-of-band management for that particular IPMI interface. So you want to know about that as a DevOps administrator, right? You want to know that my BMC no longer is active or something happened. Maybe I had a network switch failure. Maybe I had a specific port on the BMC network, management network fail. Maybe my BMC failed, right? So you want to provide some information here to be able to know that that particular appliance now is in an inconsistent state. It isn't able to collect redfish endpoints, and we were able to alert on it. We can alert on it through the GUI. We can send an alert through basically SMTP, or basically send it through webhook architecture that we have built in to our platform, and then eventually be able to send that into a collaboration tool such as Teams, right? That you want to be able to send that particular data, right? Because it's using an HTTP relay mechanism in order to send that important metadata. All right, so the next thing we want to do, if you recall or remember, it was the 200.2001.115. So we happen to have a scope of DHCP addresses in our back end of our data center that's providing IP addresses. So the BMC can be defined as a static address, or it can be DHCP. In this case, we have a DHCP type server out there that's providing scoping and leasing for the BMC, and this happens to be our MI300 Accelerated Compute. And you look here and you say, well, gee, the health critical. So what's wrong with this server? We need to find out what's going on with it. So we can click here, and then at this point, we can look at all the information in BMC events that you would see within your BMC. Like if you were logged into the BMC, we will provide all this information within the GUI. But that's going to create a number of clicks to get that data. That's going to take you time to get that data. So why not provide that within a dashboard that can scale and have all this information present? So when we have this part of the PodView registration, we then also register with what we call Redfish subscription services. So message event log information, session event log information is provided in a Redfish endpoint that we collect, and we expose it within the BMC itself. So if you had an in this case, it's an AOM NIC temperature that is critical. If you had an intrusion alert associated with the server, somebody tried to break into the BMC, we would expose that. If you had a power supply unit fail, or maybe you didn't have redundant power supplies within the server itself, we would expose all that. So all of that information, sessions event log information, and also message event log information is exposed within the BMC itself. And you can see all that data and collect it within our platform. So we now know what's going on with this platform. We've got some critical events that are going on that were inserted and basically showing sensor information, such as PLX1 temperature information is degraded or unavailable. So these are warning messages. So you can ideally take this data and basically then dump it to a Excel spreadsheet. So why would I want to do that? Why would I want to data mine this information? Like if you had 20,000 monitored hosts and you are trying to determine the critical event of all the servers, I might want to dump all that data. I might want to dump specific information about the server, because maybe I want to do some type of tracking, historical trending, right, through an Excel spreadsheet. Maybe I'm trying to do root cause analysis on this server. It's not performing ideally what I want to perform, and I want to do some type of historical trending to get an idea of what's going on. So again, this is important for DevOps administrators to be able to do this, right? They want to be able to have their data scientists provide a hardened platform that's going to run, right, all the time. So when you're running an LL model and it's running for a long period of time, you want to prevent the ability for that server to basically crash or have a problem, right? You want to maintain some bit of understanding of what's happening within your data center. So this comes very key of basically looking at, now we're moving from day 0 now to day 1 operation, potentially into day 2, of collecting out-of-bin sensor data associated with this server. So on the top here, on the carousel view, you can show here that it is in a system health critical. And then you look at various different information. If you put your mouse here within the carousel view, it'll stop scrolling. You can see how much memory you have. And we'll show you a little bit later how you can look at granular detail of this MI300 server itself. But you can see here our memory size, and you can also see how many GPUs that we have present within this MI300 itself. We have it's a 2-socket server, 2 CPUs, and then it's 384 core, shows you some local storage information for SAS or SATA, JBOD information, so on and so forth, if you had various different simplified storage in here. And of course, you have 8 local GPUs. So I would expect, because this is a GPU server, that we see GPUs within this server, and they should be MI300, 325 type accelerators. Okay, on the other information here, system information, we can look at BMC IP address, manufacturer, the SKU information, and also the BMC firmware at a glance. We'll go into more detail, show you how you can collect BIOS information, how you update the BIOS, how you perform lifecycle management for this server. So that concludes this piece or vignette. Signing off today. Wish you a great day. We'll see you next time.